This podcast is brought to you by Infrastructure Masons, uniting builders for the digital future. The podcast you're about to listen to features a panel of experts hosted by the iMasons Innovation Committee and attended by our members. We're making this content freely available for everyone's benefit. If you'd like to join future discussions and ask your questions live, become a member today at imasons.org/community/members. Enjoy the conversation.
Good morning, afternoon, and evening, everybody. Welcome to our panel. Today, we're bringing together leaders in AI optimization, power management, and infrastructure innovation to explore one of the most pressing questions of our industry. How can data center operators enhance efficiency without compromising resilience? We'll look at a few things. So tensions between energy efficiency and operational risk, the growing use of predictive analytics and real-time monitoring, and how AI-driven cooling strategies reshaping the way we manage performance. Our discussion will also touch on the practical approaches from low-capex efficiency measures to modular, scalable infrastructure that can flex with fluctuating demand, all while supporting more sustainable operations. So it's going to be a fascinating discussion that bridges technology, strategy, and sustainability. But before we get into this, let's do a couple of housekeeping. So first, if you're in the chat, I'd love to hear from you. Come on and say hi in the chat and add as well where you're from. If you've got any question as well for our panel, please feel free to actually drop them in the chat as the panel progresses, and then I'll pick them up as we go through, and I'll dish out the questions to our panelists. Just a quick reminder to keep the comments respectful and on topic. We want this to be a positive and insightful space for everybody. And finally, the session is being recorded and will be available to rewatch later. So don't worry if you miss something. You'll be able to revisit all the key insights after the stream. All right. So now that this is out of the way, let's jump into today's discussions. We've actually put together four specialists in their domains, in their respective domains, from four different companies, and they're going to come and bring the insights to our discussions. So let me get started by introducing Eric Topham, the CEO and co-founder of Octopipe, a company dedicated to delivering trustworthy AI for IoT. Octopipe's mission is to protect the world's critical infrastructure by embedding intelligent devices, performance, security, privacy, and resiliency directly into connected devices. Eric, welcome to the panel.
Brilliant. Thanks for having me, Rima. Good to be here.
We've also got JP Bazell. He is the data center chief architect at Eaton. In his role, he works closely with Cyril Bresson, Eaton's data center segment leader, to influence and support the company's global segment strategy. This includes overseeing the development of next generation reference designs and assisting customers with full data center designs and deployment across all physical layer dimensions: power, cooling, network, and software. Welcome, JP.
Thanks for having me.
Third, we've got Dr. Parag Maresh, currently the Director of Technical Sales at Vertiv, focusing on data center energy solutions. With over 18 years of technical program management experience, Dr. Maresh has demonstrated success in building and leading multicultural teams, transforming operations across continents, and driving sustainable practice. He holds a PhD in mechanical engineering from the University of California at Berkeley. Welcome, Parag.
Thanks, Rowan. Glad to be there. Looking forward to a good discussion.
And last but not least, I'm hoping the technology is going to work. We've been having a couple of troubles in getting Daniel into the room, so hopefully he will hear us and you will hear from him. Daniel Turk is the global portfolio manager at ABB Data Centers. Daniel's expertise focuses on electrical systems, and he has an in-depth experience in a wide range of areas covering product management, marketing, and engineering. He is passionate in supporting segment growth to integrate sustainable solutions and new technologies. Welcome, Daniel. And I'm not sure he can hear us yet. So we're going to try and fix that as the panel is ongoing. Let's get straight into the topic. With the advent of AI raising densities, a closer integrations between the IT world and the facilities world, we've seen a number of strategies evolve over time, or at least emerge in the recent years. I'd love for our panel to take us through how can operators balance energy efficiency gains with operational resilience while adapting to new infrastructure form factors and innovative techniques. Who wants to get started?
I can go, Roman. I guess this is an excellent question that I think everybody is asking. I believe it's going to take a multifaceted approach. We have to do many things together in a right way, but I will prioritize four of those as the most important focus areas, and those: integration, automation, innovation, and risk management, right? So integration, we know data centers have both power and cooling as their requirement. So how can you integrate those requirements into one solution while maintaining redundancy and optimizing energy use? We have seen as much as a 25% decrease in cooling energy consumption with the integrated solution, along with enhanced redundancy. And also the other piece that is important is to be able to do real-time load balancing, which will help you improve the capacity planning. So those are some of the areas where the data center operators can focus on from an integration perspective. The other areas of focus, as I said, was innovation. So the UPS systems, for example, have come up with this eco mode operation that balance efficiency and availability. We have seen as much as 30% reduction in energy costs and PUE improvements. Significant PUE improvements with 5 nines of reliability. So there's lots of innovation in that area that will help. The third piece that I think we need to be focusing on is doing risk management. As you said, the architectures are evolving, the needs of the data centers are evolving at a tremendous speed. So when we do these transitions, we do phase transitions while maintaining redundancy for critical systems, and also develop clear while testing the redundant systems, regularly, to make sure that they will function when they need to be functioning. And the last piece I would say is having real clear performance metrics that you can measure, and make sure that you have a good way of monitoring your PUE, tracking your equipment reliability metrics, and also just analyzing how your energy consumption is happening throughout the data center, and just keeping an eye on those performance matrices and comparing them over time to see where you can improve. Efficiency would be helpful.
Fantastic. Thank you, Parag, for your introduction to this topic. I'd like to welcome Danielle as well, who finally got the technology working. So welcome to the panel.
Hi, guys.
And so, JP, Eric, Danielle, do you want to take a stab at the first question? So just for Danielle's benefit, so how can operators balance energy efficiency gains with operational resilience? All that whilst still adapting to new infrastructure form factors and innovative techniques. So who wants to go next?
I'm happy to jump in because I would say, actually, just listen to Parag. There's an extra that I would add to his list, which fortunately rhymes with the others, and that would be collaboration. So I think when we think about the application of particularly machine learning or AI-based automation systems, automation as a paradigm isn't necessarily actually the right way to apply some of that technology, particularly when we're in critical environments where perhaps historically we have a sort of a conservative approach to risk and operational resiliency. And in fact, what we want are to design collaborative systems. So systems that collaborate both within themselves. So when we think about what we call multi-agent systems, we have machine learning based agents that might look after the optimization of the control strategy of the cooling, but those would collaborate in a joint optimization with other agents that might be, for instance, optimizing workload scheduling and allocation within the IT stack. So we have collaboration there, but really also what we want is collaboration between the human operator, the expert engineer, and those systems that are able to behave in a sort of hybrid automation or collaborative mode in sort of hand in hand with the operator. And I think that's a really key part of balancing the gains that we want in efficiency from these more dynamic systems that we recognize we can get efficiency gains from, while at the same time ensuring that we have some reassurance around the oversight that we have to kind of ensure that we have that operational resiliency. So I think it's a really key thing, like we read all these wonderful sort of marketing wins around the amount of energy we can save from fully automated reinforcement learning systems and so forth, but the reality is that actually in order to kind of balance that out with the operational resiliency piece, we need to carefully design systems that operators can trust and that operators can collaborate with. So I think that's kind of a crucial part of it.
And absolutely, I would add to Eric's point as well. The collaboration is really a good word there, and it also has to be in between the different systems, right? I mean, of course, we can gain a lot in the electrical system, or we can gain a lot on the cooling wise. But if we add also the predictivity on the load, or using a digital twin, we can run the different systems as well, and then collaborate with the human factor and so on. So the systems definitely will go more complex as we gather more data there to be more smarter or more optimized. But definitely the collaboration is a good word across the whole the site or industry or the whole system.
Yeah, I think taking, all the comments are fantastic. Thinking also the end in mind, right? So sometimes you don't need 5 nines of reliability, and that might probably give us some opportunities, right? So the training models that have the ability to be interrupted, you might be able to have a cluster that's tolerable to 3 nines of reliability. But on the opposite side of that, if you're using the actual workloads for inference and it's critical infrastructure, 5 nines reliability might not be enough. So there's a balancing aspect on that, and what the previous comments were, summarizing that together with how is it actually being utilized, and then what can we do to optimize so there's not waste.
So we definitely have a chicken and the egg situation here. A lot of the workloads are AI for trading and inference that we start seeing going into data centers. This is triggering the paradigm shift for renewed different types of cooling, but also power distribution and form factors for data centers. And at the same time, we're using that technology to help manage the entire infrastructure that, as you guys are saying, is growing in complexity. So the question for me is, we're first of all, do we want to work in a far more automated fashion? So, do we want predictive analytics? Do we want real-time monitoring to transform on-site energy utilization? And do we want to apply it everywhere? Is there maybe use cases where it's more favorable, or maybe use cases where we wouldn't want to change the way it's been done so far?
I think the switching characteristic is really going to come down to, do we trust it, right? So I'm an advocate of more automation because it'll give more leverage and also allow us to think a little more clearly and give the operators better judgment calls to clear away some of the noise. But I think there's going to be certain critical aspects that if you have like the network room, you might want to have a little bit more human control before that switches, because if the network goes down, rebuilding the site is a significant lift opposed to a server going down. And it's not as much of a lift.
Yeah, and I think. Oh, sorry, go ahead.
Go on, Daniel. So, yep, please go on.
Yeah, I think we need to also expand a little bit of thinking behind the different application. Not really. If we look today, we talk about a lot the hyperscalers or the co-location or the edge, but actually the application is driving a lot more. Application, if it's a machine learning, starts also to drive which kind of architecture we are using, or really by which architecture do we need, how much the UPS or the redundancy we need. So. Or if it's a more on the edge, it's also a little bit of different architectural demand on the electrical system. So I think we will see further on the sub segmentation or the little bit of different segmentation, not just the high level ones. And do we really need this one? I think we need, because the systems are going more energy hungry in a way. We need to look how we can be more sustainable, or how we can use the available energy more smarter, because all the gigas that are planned for the market, we also need to match within power generation, right? So we gotta be a little bit smarter there, definitely. So I would say we will need, and we also need to run our system much smarter than it is today.
Yeah, I mean, I would agree. I think like there's this old idea that between money and physics, the thing that will run out first is money, right? And so and so inevitably that means that you're going to have to drive towards efficiency at a certain point. And efficiency in itself, when we think about so I remember being on a panel some months ago when sort of the DeepSeek piece came out, and how shocking that was for people that weren't kind of in the machine learning industry, and for us that are here, it sort of wasn't surprising. People have been trying to make models more efficient for some time, and everybody said, oh well, is this going to kind of sort of completely sort of upset the AI market? What does it mean for demand? And in fact, there's this thing called Jevons paradox, which is where if we can generate better efficiency, what actually happens is that you land up driving greater demand. So in fact, not only is it kind of a necessity from the point of view of the economics of the infrastructure that we're building and the need to at some point bring efficiency to it, and secondly, it's actually something that's probably beneficial for that industry in the first place. And I think from the sort of the machine learning world side of things, I think internally we all know that the current paradigm of what kind of from the outward public world we see as AI really is a sledgehammer approach to things, and at some point we're going to have to drive economically for something more efficient. So inevitably the underlying infrastructure is going to have to do that. The second point I'd make is I completely agree with the point on trust, right? Internally at Octopipe, what we talk about is our design philosophy is trust first, scale second, performance third. If people don't trust it, they won't use it. If they won't use it, you can't scale it, and if you can't scale it, there's no point having all of the performance in the world. So again, I completely agree that in this kind of equation of how do we balance that operational resiliency and the efficiency that we think economics will drive us towards, that trust piece is absolutely critical.
Yeah, I agree 100% with all the panelists here. I think, from an energy demand perspective and utilization perspective, having the real-time energy management systems and predictive capabilities are going to be critical. One aspect is to just being able to anticipate when does my equipment need maintenance, and how can I plan for it ahead of time, rather than just trying to put as much backup as possible for worst case scenarios, right? So if I can predict failures, in an improved fashion, I may be able to, put the energy piece a little bit better, right, from a perspective. The other aspect that we have to think of it is, is the industry ready, and what needs to happen, to be able to do these real time energy managements and predictive capabilities, right? What sensors do we need? How, what's going to be the network connectivity demand? Do we need systems that can help us collect, the data and security piece? I think Eric was talking about the trust, right? People should be able to trust the the data storage system. So there's lots of those. Do we have standards in the industry? and I think we talked about the money, right? Everything costs some investment. So is there a return on investment, from that point of view? We definitely need to make sure that we have clear implementation roadmaps. We have the ROI models to be able to justify the investment, and collaboration. I think somebody talked about that earlier in the, just having the strong vendor partnerships to develop the right infrastructure to be able to do it for industry-wide use is critical, in my opinion.
Parag, I'd like to pick up on one of the things that you said, which are quite important. There is there is a point where you said that basically, and the trust is basically trust and risk are pretty much related, right? And so in reality, if we want to build trust, we need to fully understand the risk. And so on that basis, I'd like to invite you all to actually comment on the number of new technologies we're seeing being implemented on site, and how and to what degree do you believe operators, maintainers, OEMs, and so on really understand the level of risk through all of the new technologies that are being deployed? And I know this is a bit of a weird question because we've got 3 manufacturers on the call today, but I'm still going to ask it because I think this is quite important, right? To really make the link between being able to install brand new equipment in new setups and new arrangements, and how they and what risk they might generate on site, and maybe offer some proactive steps that buyers should be able to ask you or to do for themselves.
Yeah, sure. So I think from our point of view, we would say there are multifaceted risks, right? So there's risk on the operation side, and there's a security risk that we talked about. Some technical risk because you're putting new technology into the system, so there's going to be some technical risks, and then just the risk to the personnel, in terms of the need to understand the new technology, right? Some of the ways I would say we can overcome is the phased implementation approach, right? Just go and deploy in a phased manner. Also monitoring, we talked about predictive analysis, regularly monitoring the performance, of the system. Just testing from a penetration testing perspective, what impact does this technology is having in my critical performance indicators, and how am I measuring those, from a technical risk perspective, just doing detailed technical assessments and proof of concept testing, making sure that vendors are doing their part in there as well, and then documenting those updates are critical. I think one of the pieces that we absolutely have to be careful about is the personal risk, right? Making sure that we don't leave any knowledge gaps in the space of the person who are working inside these data centers, and so putting together robust training plans, and making sure we have the clear documented processes in adapting that technology, and being able to allocate the right amount of resources to do that is really, really important. And then the last piece is the business risk, right? Like, we want to make sure any technology adoption doesn't really cause budget overruns or timeline delays, because time is money in today's world, as we talk about. So making sure that you have clear success metrics in there. Compliance is becoming a big thing, so we want to make sure that compliance monitoring is part of your plan, and then also just business continuity planning in case adoption goes sideways. How are you going to continue your business is part of the analysis as well. So I think from my point of view, yeah, there are risks, but none of those risks are such that they cannot be managed with proper planning and design.
Yeah, I mean, from the manufacturing point of view, I also have a past experience with product management. I can tell that all these models to make a product proved to sell to the customer in some of the industries are really taken seriously, and electrical is one of them. So really, sales always wants to go and sell the product, even though it may not be industrialized till the end, to start getting a pilots and so on. But I would say in electrical industry, if the product is launched and released, usually it goes through a very extensive testing, either from safety point of view, compatibility point of view. So there is really a lot of work into it. Just a one comment on the standard as well with the new technologies. As we see, world is evolving very fast, especially lately, and especially with the power electronics, we see a lot of changes. There is not that good regulation in the data center industry still as a standard, and this is also evolving, I would say, very fast. So data center industry has put electrical manufacturers to move faster, innovate faster, come out faster with a product. But I would say the general level that the products are tested and ready to the market are still in very high level.
I think if I was to chip in from the machine learning and AI driven solution side of things, I think that it's completely reasonable to expect that the average operator won't fully appreciate what risks exist with those systems when they're implemented, and so it's absolutely on the developers and the vendors, people like us at Octopipe, to build products that allow the customer to actually appreciate the risk, be educated through the use of the product, and perhaps even have some agency in the management of that risk in terms of what the product will do for them. So from a kind of taking risk and flipping it the other way, which is trust, in the machine learning world, we talk a lot about trustworthy AI paradigms and what you need to do, to build systems that, help people understand and manage the risk. So having systems that are not black box, that are explainable, that are able to explain, and these days we can do this, we can actually explain in natural language to an operator why, for instance, a reinforcement learning algorithm is making a set of, for instance, set point change recommendations. We have the technology to do that. That's critical in both, on the one hand, explaining to the user why a change is happening or is being recommended to happen. At the same time, it's also critical for creating, for instance, audit trails, so that later, if there is any kind of issue down the line, we can deal with it. I think the other thing about risk is, for me, I often see, when we go into data centers, I see quite a lot of risk in the fact that we tend to have a lot of sort of disparate systems that have been sort of cobbled together sometimes with a bit of grey tape and glue, and so there's a kind of an integration risk there when we try and then add these data-driven systems, where if those different subcomponents are not tightly integrated and robust, of course that can have some impact on the performance of that system, which will then impact something else down the line. So I think going forwards, what people really do need to understand is, if you're going to use and embrace those systems, some real thought needs to be put into how is your infrastructure built, designed, integrated. Is it as unified as it could be? I think having more unified, certainly in the software stack below the machine learning, having a more unified infrastructure and even standards would be extremely helpful. And so I think that's an area of risk that people kind of really, I think, underappreciate at the moment, as far as we see it in the industry.
Yeah, I think good comments so far, and like a lot of these have been on the what's the risk of adoption, but to flip it, what's the risk of not adopting is something that also needs to be addressed, right? So currently, with the technology portion, specifically around cooling and electrical, the risk of not adoption currently will, for certain organizations, will slow their ability to absorb next generation compute that's coming down the line, and that's a significant piece. And touching back on the regulatory requirements, we have to bring them along at the same pace, right? So there's been significant meetings with UL 2 weeks ago, and significant meetings with IEC and Current OS, which is the DC DC Alliance, to help bringing those individuals along and tying them into the overall ecosystem with the open compute and other bodies as well.
Yeah, thanks very much for all your inputs. And so I'd just like to invite maybe one comment, like a short comment from Parag and Danelle. So I was just showing that comment from John earlier. It says, but what compliance requirements or regulatory requirements are you referring to? Do you have any in mind, or is there anything that your companies are adhering to?
Yeah, I have one in mind, and this is the hot potato at the moment in the industry, right? We are talking about the power increase, and we are talking more and more on the direct current. And if we talk more on the direct current, then looking at IAC standard or looking at UL standard throughout the full value chain of the products and the solutions, then there are still quite a lot to do. I'm aware of that OCP as an organization does a good job. There is some other organizations who also are doing a good job to get up to the speed with it. So yes, we all work very hard on it, but definitely there are gaps that also the standard wise we have to close as well as industry.
Yeah, I think, Roman, from my point of view, I agree. Daniel, there's new standards, regulations that we have to be aware of, and then there's some existing ones, right? So the new ones, that we have to be prepared for, bring in the flexibility. One of the things that is going on a lot right now, as the data centers are becoming larger and larger loads on the grid. I just came back from a conference, and there was so much talk about how are they going to respond, from a voltage right through and frequency right through perspective, and there are changes in that. That's kind of coming up. That's going to be a compliance, requirement on the data center. So we have to be prepared for all of these changes, that are going to come to the industry, because sooner or later we are kind of becoming the larger portion on the energy grid as well. And there are other standards, right, from a air permit and UL and IEC that we just talked about, that are existing and I think well known in the industry. But then there are some new ones, like Daniel talked about the standards for the DC architecture, as well as some of the voltage right and frequency right through standards that are coming up.
And just as example, if we take also the more equipment we switch to the network, all the cyber security is coming all quite important as well, right? So in the last 20 years, the industry for the medium voltage with the relays, making sure that the products and all are cyber secure. So there are standards coming very, very often with the new updates and also with the products. We see more and more often the security updates pushed on the system, simply make the products more cyber secure, and so this is also one area, for example, that evolves very fast.
So from looking at regulation and compliance, to be able to standardize that across, we're going to have to talk about KPIs, right? And that's one of the things that has been referred to over the years with data centers. PUE comes to mind as the primary KPI that people have been talking about for a while. And actually, Theodore in the chat has beat me to the punch with a very good question. I was going to ask in particular, and then we'll add Theodore's question to it. What operational what operational changes deliver the largest immediate efficiency gains and maybe PUE improvement without significant capital investment? But what I'd like to add to this is then PUE the right metrics when we're trying to optimize? Is it the only one, or we're looking at other ones? And also, which ones are actually insightful, which ones actually drive change on the site? Anybody wants to take a crack at maybe combining the two questions together?
I think the cooling mechanism matters. PUE and the other KPIs that were developed for an air-cooled world. Now that we're getting into hybridized air and liquid cooled, PUE might not be how it's currently calculated. Might not be the most uh, effective indicator. TUE paper that was dropped probably about a year ago might start to explore that topic, and then getting into more of like the tokens per watt aspect for power, and then how that's overall utilized. That's just more on the energy consumption factor. But then if you want to also drive overall sustainability, looking how we're using the carbon is also an important factor as well. Um, it's particularly important because PUEs has now become part of how we contract. So an air-cooled data center with a PUE and the other KPIs would be significant, but as you go into a liquid-cooled data center, I think those might need to be reevaluated. Curious on everybody else's thoughts.
Yeah,
Go
I
ahead.
think on the industry wise, we talked already. Somebody mentioned the DeepSeek, which kind of puts people to think. I think that if we look at data center industry, it's on a beginning of the new chapter as well, and really the measurement methods. It really worked, as said earlier, on the current or earlier cooling with air cooled systems, but the whole architecture is in a beginning of new step and new era. I think the new also measurement has to come to the picture as well. I don't have it right now the silver bullet to say what fix it, but I think the complexity of the system, the new power era, new ranges, everything is changing so much that we need to rethink how to measure it also.
Yeah, I think from our point of view, I would say PU is still significant but not sufficient, right? Necessary but not sufficient condition, right? We have to have good PUE just from a utilization perspective. But then some of the other pieces, especially when you talk about a lot of data centers are now also thinking of on-site power generation, right? So when you talk about on-site power generation, then the other piece that comes into picture, and what we kind of measure sometimes is how much fuel that's getting consumed that's actually going to be used to create the tokens, because tokens is the money, and how much are we using to actually support the critical IT infrastructure. Now that's, that somebody can argue that's probably the PUE definition as well, but when we think of it from a powertrain perspective, and that kind of gives us a clear picture. The other piece that I think is important, and it's probably not an energy efficiency point of view, but in a whole it is really the deployment time, right? How much resources are we using to be able to deploy a data center? And we are, and I know we were probably going to talk a little bit about modular designs in future, but we are developing deployment ready data centers, and with standard designs that can cut down up to 50% of the time in deploying. So all of those are resource used to be able to actually build infrastructure, and we can help reduce that and improve the overall efficiency from a overall carbon footprint perspective. So I think we have to think at it from an holistic point of view. Once the data center is in, then what are the KPIs? But then there are other ones that I think are required to measure before you are actually ready to deploy a data center.
So I'm loving the discussion, and also I'm trying to keep my eyes on the chat, and I'm glad that all the people listening today are making this hard for me, because there is a lot of comments coming through. So I'm just gonna put one up, because that was there was a very specific one from Miguel. So in Latin America, where power grid stability and energy costs can vary significantly between countries, How do you see AI-driven optimization and modular data center design helping operators build both efficiency and resiliency, especially in markets where energy redundancy and renewable integration remain inconsistent?
Well, I'm happy to pick up a piece of this that caught my eye. So I think what's interesting about some of these, people talk about them as AI, I always think of them as machine learning driven optimization systems, is that efficiency is one potential objective function, but system stability is another one. So particularly where we think about use cases around demand response and so forth, here we can actually have some quite beneficial effects back into the grid in the way that we're able to kind of more intelligently manage the systems on the DC side. I think what's really interesting about the modular data center piece is that it's interesting that if we're able to roll out sort of deployment ready modular data centers that are architecturally the same, from a machine learning perspective, it makes it much easier to learn effectively to teach the machine learning the thermodynamic responses of a system that then perhaps varies more in terms of the environment or the climate that it sits in. And what that opens the door to is the ability to use more advanced collaborative, or what people call federated learning systems, where we can have machine learning systems at an individual location actually collaborate securely with other machine learning agents in other physical locations in order to find and scale, if you like, the learning of an optimization strategy. So in places where we're able to deploy that sort of architecture quite quickly and scale it up, it opens the door to being able to quite rapidly learn optimization strategies as that infrastructure scales out. And so that's a really attractive thing. And here at Octopus, we've got a few customers that we're starting to work with that have this paradigm of blueprinted modular data centers that they want to scale out across a region, and they're interested in how they can actually leverage that sort of distributed training of the optimization algorithms that are inside each of the individual units. So I think that's a really kind of interesting paradigm that we're starting to see in some of those markets where there's a little bit more kind of greenfield the infrastructure rollout, and ultimately there are use cases that machine learning driven optimization can really help with issues of balancing out for things like demand response and grid stability, or even indeed switching between unreliable but somewhat predictable energy sources that might be connected into a smart grid or such.
Yeah, and for Miguel, don't worry, it's not only Latin America. We see the similar challenges also in the Asia Pacific as well. The modular solutions are really giving a number of different benefits. You can, as said already, you can save time on site, but you can also use the similar equipment in a different site. So if you get further with the planning, you can decide which site to go. In the past, we also have seen the market can change from one to another country if the energy prices are not really where they should be. So they can shift it to another country. So it's not really the problem in Latin America. On the efficiency wise as well and resilience wise, as we see if data center operator runs a different or multiple data centers, they can optimize between the different sites, and they can transfer or collect data more into the site where it's more optimum as well. So definitely the digital twin or the AI driven optimization will come to the picture there. So
in fact, it's interesting. What you're saying there reminds me, Daniel, that one of the really kind of interesting use cases of this form of sort of distributed or federated machine learning isn't just the collaborative training cross-site of algorithms that are involved in the management of the infrastructure, but in fact, if you considered a fleet of AI data centers where we're executing training workloads, for instance, we can push data into a location where either we have a better green energy mix, or where the price is beneficial, and we can split data sets across geographically separated locations and still execute training jobs across that fleet. And in fact, it sort of opens the door to being able to improve your IT utilization efficiency, because you can push workloads into pockets in individual clusters, but shard that training across the fleets. And I think that's a really interesting thing, not just for the kind of the modular paradigm, but also for the edge data center market that might be looking for kind of other ways of monetizing their assets from things like offering GPU workloads and so forth.
Exactly.
Yeah,
So yeah, sorry, go ahead.
I'm agreeing with saying, like, when you're shifting it, a lot of the conversations has been around going back and forth with the software shift. But I think what Daniel was mentioning was quite interesting. When you double click on how you engineer the actual module, you can move that module later and swap that asset at a different place. That way you can reuse that capital, right? So you might have already utilized that capital, and but the capital won't be stranded in a certain place physically. And if you make it in a modular nature, it can be moved around on top of the software, because capital is precious everywhere, not just in LATAM. So don't feel alone in Latin America. Yeah, Daniel, sorry, go ahead.
Yeah, and this capital actually, I mean, if you look electrical system, then the lifetime of is like 20 years or whatsoever. So again, you can reuse that in other sites. The one challenge what Eric comes as well is that countries are putting in more and more regulation that data has to stay in the country. So that limits a little bit. It's easier in the Europe, I would say, but in Asia as well, there are more and more, unfortunately, regulations like that. So you cannot really transfer the data. But yeah, still, it's possible to do it in many locations. So.
The other piece that comes to my mind, from a modular point of view, is the scaling factor, right? You can actually scale the data center. We just talked about the risks, and how can we manage those risks. And one of the things that we talked about is the phased approach of deployment. And the modular data centers really allow you to do that, a phased approach in terms of the deployment perspective. And the other piece that was talked about was the AI driven optimization. I think that's a critical adoption. JP talked about the risk of not adopting something. I would say that's a big one, that every data center operator has to really be aware of. That brings in a whole suite of new possibilities, right? You can do a lot of predictive load management, temperature adjustments, cooling. Could be as much as 40% of your overall power use in a data center. So as much as you can optimize that cooling power requirement, the better it is, right? Automated airflow controls, some smart sensor integration. Those are all the possibilities that kind of come up when we talk about the AI driven optimization of an overall system. The other piece that we talked about is the predictive maintenance piece that kind of comes into as an AI driven optimization schedule as well. So I think there's a lot of possibilities, and something that we will have to adopt industry wide, both AI driven optimization and modular data centers for where the industry is today.
So I just wanted to bring up one of the comments from Darius. He said, with respect to other or new metrics, does anyone have any practice with energy reuse effectiveness? And whilst I want to invite our panel to talk about it, if you actually do, I'd also wanted to thank Steve for sharing this with us. So NWEL has had a paper out in 2012 about this. So just in case anybody wants to go and have a look at it, he had put it in a comment and got 2 thumbs up. So I thought it was actually worth sharing. Any comments from our panel on ERE?
So from our point of view, I don't know energy reuse effectiveness, but we do work on reuse of energy that is consumed within the data center into other pieces like whether we can convert it into something that can do cooling and help us reduce the cooling load, like I talked about, or just Europe, we have seen cases where the data centers have been used for district heating and those types of things. So that's the energy reuse that we have seen deployed in data centers.
Brilliant. Thank you, Parag, for the insights here. We've got about 10 minutes left, so keep coming the questions on the chat if you have any. I've got one on my side. So we've talked about AI-driven cooling optimizations, but and we often talk about it at the site level. So we take one piece of infrastructure, apply AI optimization on top of it. I just wanted to see, is there anything that's being done maybe at a portfolio level? What impact does it have? Does actually help to actually then do aggregated learning beyond just a single site?
Sounds like that's one for me. So the answer to this is yeah. So I mean, one of the very special things about what we do at Octopipe is that we actually so we're fundamentally a deep tech company. The core technology that we developed and have then applied into the data center from a machine learning perspective, something called federated machine learning. So federated machine learning is a form of totally distributed, highly secure machine learning that is designed for sensitive or critical infrastructure operations, where we want to be able to scale the training of machine learning algorithms across a number of nodes in a network while not having to actually retrieve the data from them. And what's really interesting is that what we find is that if we use this technique to scale the training of, for instance, reinforcement learning algorithms that are undertaking machine learning based optimization of control strategies, for instance, for set point management in data centers, what we find is that we can have agents that have been aggregated across multiple sites that then outperform in terms of the efficiency gains that are delivered any of the individual agents, individual sites, but also are more robust to changes in the operating conditions and the environment of the data center, effectively because you've had a sort of a collaborative learning experience across a range of different operating conditions and environments that go beyond that experience by any individual site. We're able to actually account for differences in cooling systems, IT loads, climate, and so forth in how we do that. So not only do we get better performance, but we actually get more robust algorithms that also behave in a more stable fashion and are good in terms of the stability of the systems that they manage. So this is a really nice paradigm. There are lots of use cases that we can actually apply this to, not just set point management. We can do this for things like IT workload scheduling and allocation. We can do things like learn efficiency curves from operational data across multiple sites. Sort of the list goes on. But that is a really kind of powerful paradigm for being able to leverage better the data that's generated from within the infrastructure and the operations of the data center, but across entire fleets, but without having to really compromise on the security side when it comes to the data that's being generated and managed within an individual site. So that's, I think, a really kind of powerful paradigm that's very different from the kind of cloud-based systems that we're used to hearing about when it comes to machine learning.
Yeah, and if I may add one more point, I think those are all excellent points, Eric. But one other thing that we can also achieve is just the coordinated maintenance planning, right? Being able to actually manage a portfolio of sites and being able to manage the maintenance planning of it. Maintenance is going to be a big cost from an operation perspective, and if you are able to catch multiple sites in one go because which systems need maintenance at those given sites. That's a piece that I think is going to be a very critical benefit of portfolio management rather than just a site management. And that's something that I'm sure all the vendors use for their service, offerings. So.
Yeah, absolutely. I completely agree. The world is sort of becoming our oyster when it comes to sort of multi-agent systems that can manage, multiple assets either within the site in an integrated and coordinated fashion, so effectively through joint optimizations, or indeed across multiple sites within a fleet. And I think that piece about maintenance scheduling is actually a use case that we're seeing come up repeatedly with people sort of talking about self-healing data centers and wanting to be able to estimate when the optimum moment for part replacement and so forth, and planning downtime to minimize operational impacts. I think it's a big part of it, and I think managing infrastructure more holistically like that is important. And I think within the data center itself, which is fundamentally a complex environment, if we don't have these joined up systems, what you end up with is a bunch of slightly disparate things that may be sort of integrated, but not at the point of the management of the system as a whole. And so you can land up with sort of unintended consequences when you try to bolt some of those things together. So
yeah. And I really like to expand a little bit, Eric. You touched quite a good, very, very good points. I think we can talk hours on this one. But what medium voltage relay systems has, for example, went through is that they have added also the AI model. And quite a lot of things in electrical system happens due to the physics as well. You can see the disturbances, you can see the power changes, temperature changes, and all that is now implemented to the new relay systems. So if you have a multiple sites, you can have a AI learning on it, and you can start predicting that, hey, we saw the similar activity 2 years ago in that site. Please go check, because in a 2 week time or 1 week time, you may have a failure. So all these kind of AI is not only that, hey, let's build more data centers. It really uses the industry to advance as well. And I think the relay systems with this kind of predictability is really giving a good advantage. So you don't need to go and make a service by the schedule anymore, but you will get the heads up the failures. So
I'd like maybe to invite JP for a final comment as we're nearing actually the end of the panel. JP, any final thing that you wanna bring up to the panel on operational efficiency versus risk? What's your final take on this?
I think there's a blend that can be achieved, and the comments have already been done with, utilizing more software to do that, and then also understanding how to do that predictive software for the subsystem oscillations and also the AI power bursting. Recently, we publicly released some data on that in September, but when you take those things into account, you can actually work much more symbiotically with the grid operators and the TSOs, and that's going to be key moving into the future to mitigate the risks around power.
Thank you, JP, for those final comments. I think this is all the time we've got for today, and I've seen more questions that actually come through, so I will aggregate those and see if we can do further answers. But first of all, thank you to Parag, JP, Daniel, Eric, for taking your time and actually coming and answering the questions today. I've thoroughly enjoyed the discussions, and I can see in the comments as well that you've steered quite a storm of and a flurry of questions, which is nice to see. So a couple of comments from me to close off the discussion today. First of all, I want to mention that we're having another panel in 3 weeks' time on the 29th of October around the court of public opinions. So can digital infrastructure win its case? You will be able to register just like you've done for this one through the iMasons website. So you will be able to do that right there and then. Because we record those episodes when we're able to do so, we will put them on the podcast. And in case you are wondering where to find it, any good podcast applications should be able to find iMasons Innovation Podcast, and you should be able to see all the episodes we've actually released so far, both panels and interviews that we've done so far. I can see that there is a number of discussions that has been going on in the chat. So in case you haven't been able to catch an email address, a contact, or anything like this, feel free to reach out to me. And I'm more than happy to introduce you to any of the people, either in the chat or our panelists, if that makes sense. So feel free to reach out there. The discussion will continue on our Mobilize application. So this is where you can find all of our partners, members, discussions happening for all of the discussions that we're having. And then a final word for me as well. Whilst my face is always on those panels, because I'm the one asking the questions, there was a whole team behind me that actually does the work of inviting people, making sure we've organized everything correctly and so on. So I just want a big thank you to the iMasons marketing team and the innovation leadership for putting all of that together and making us have a great time together. So once again, thank you, everybody, for coming to the podcast today, being part of that conversations, to all of the people in the chat for all of the questions and all of the insights we've been able to share today. So until next time, stay connected, stay inspired, and we'll see you soon. Take care.
Yep.
Thank you.
Bye.
1, 2, 3, 4.
Infrastructure Masons is a global, non-profit, professional association of individuals connected and empowered to build a greater digital future for all. If you too want access to networking events, forums, and summits that foster innovation and influence, register now and join the other 6,000 committed participants at imasons.org/membership application.